Hey everyone. All right, so today's lesson is going to be on writing equations and inequalities. So this video is going to focus only on equations. We're going to kind of break this into two different lessons, but it's the same basic principles. So our essential question is, how can I turn a word problem into an equation or an inequality? So anytime they give you a word problem of a mathematical situation, I want to be able to turn this into an equation that I can solve for different answers. So whenever you're writing an equation, you must always remember to P. And I know that sounds kind of funny, but it'll help you remember. So writing equations is all about the importance of P. And P stands for per, each, and every. Anytime you see one of these words, I want you guys to go ahead and box it. Per, each, and every. Anytime you see a per, each, and every, 99% of the time, that's going to be the number that gets the variable in the equation. So what I mean by that is, let's say we had per 5. When I go to write my equation, it's probably going to be 5x. Right? So anytime you see the word per and a number, that is going to be the number that's paired with your variable when writing your equation. So here's an example of what you guys are going to be expected to write and then solve. So DeAndre wants to rent a bike to go around downtown Fort Worth. So Evelyn's bike shop charges $4 for a helmet and then $2 per hour for him to rent the bike. So right off the bat, I see one of my keywords. I see that per. So I'm going to go ahead and box $2 per. So there's one of my keywords. Paula's shop charges a $1 fee for renting a helmet, but $5 per hour. So once again, there is my key per. So we need to write an equation to show this situation. So I purposely did these in different colors so that way you can see the two different parts of the equation. So first we're going to write the equation for Evelyn's side. So here, if Evelyn charges $4 for a helmet and $2 per hour. So like I said, anytime we see the per, each, and every, that number gets my variable. So let's say my variable is going to be h, because we're talking about how many hours DeAndre is going to be riding his bike. So we have 2h. Now, in addition to that, every hour, he has to pay an additional $2. He has to pay a one-time fee of $4. So we're going to say plus 4. So that's important. That's one of the other terms I'm going to use is one-time fee. So if DeAndre is riding his bike for 1 hour, it costs him $4 to rent just the helmet part that he has to pay. If he rides the bike for 10 hours, the helmet is still only $4 to rent. The bike is $2 each and every hour that he is on it, but the helmet, it doesn't matter if he's on it for 10 seconds or 10 years. It only costs him $4. So that is my one-time fee, is always going to be over here by itself. Another way to remember that the per, each, and every gets the box, when we go to solve the equation, right, draw my line, box my variable. Well, when we go to box it, we are still going to box that side, right? We box our variable, we're boxing our per, each, and every. Now let's go to Paula's side. So Paula's shop charges a $1 fee, so notice that keyword there, one-time fee, for renting a helmet, but $5 per hour. So right there I see my per, each, or every. We've already boxed it. So I'm going to do 5h because every hour if DeAndre goes to Paola's shop, every hour he's having to pay $5 more. Now, her helmet is a little bit cheaper fee than Evelyn's, right? So he only has to pay $1. And so I get a 5H plus 1, or is equal to 2H plus 4. So on the left-hand side of the equation, we have Evelyn's shop. $2 per hour plus $4 for the helmet. On the right side, we have Paola's shop. $5 per hour plus $1 for the helmet. So we have now turned this written situation into a mathematical equation. And this is going to take it a little bit further, but I want to go ahead and start talking about this because this will help us when we go into our next section, which involves graphing and slope and equations of lines. So if DeAndre decides to go to Evelyn's shop and he says, okay, I want a bike, so he pays the $4 for the helmet, and he's going to have to pay $2 per hour, and he immediately says, you know what, I regret this decision. I don't know how to ride a bike. I'm returning my bike. So he biked for 0 hours. He still had to pay Evelyn $4 for the use of the helmet, right? He doesn't get that money back. He still rented the helmet. They still have to pay to clean it. So let's say he went out and he biked for 1 hour. Well, he had to pay the helmet fee, which was $4, plus $2 because he biked 1 hour, for a total of $6. If he biked 2 hours, well, the helmet fee doesn't change. However, he had to pay $2 per hour. So if he went out for 2 hours, 2 times 2 gives me 4. So then he would have had to pay Evelyn $8. And same thing, so if he went out for 3 hours, the helmet fee of $4 did not change, but now $2 per hour for 3 hours is $6. So he would have to pay $10. Now let's look at Paola's bike shop. So DeAndre puts on his helmet, decides, nope, I regret this. I don't want to do this anymore. So he biked 0 hours, but once again, he still has to pay for the helmet. So Paola only charges $1 for the helmet. So he's getting a little bit better of a deal there. Now let's say he goes and decides to bike for 1 hour. He has to pay the helmet fee of $1. But Paola charges $5 per hour. So he biked 1 hour, so $5. 5 plus 1 gives me 6. He goes out and bikes for 2 hours. Helmet fee does not change. But if he's 2 hours at $5 per hour, 5 times 2 gives me 10. He now has to pay her $11. And same thing for 3. So 5 times 3 is 15. So $5 per hour for 3 hours. Plus the $1 helmet fee gives me 16. Okay, so that's getting a little bit further. Going back to the writing equations part. If you can find your per, each, and every and separate it on one side and then on the other side, this is going to be super easy because anytime you see your per, each, and every, box it. And once you box it, you know that's the number that's getting the variable. Because when we go to solve it, we have to draw our line and box our variables. Well, we're boxing whatever the per, each, and every. So we've already got it boxed. So we're kind of working ahead. And it kind of helps us connect these couple of things together.